Somewhere in the North Pacific Ocean, a submarine is moving. No radar can find it. No sonar can track it. No satellite can photograph it. The most powerful militaries on Earth have spent decades trying to locate it and failed every single time. It carries 20 nuclear missiles, each one capable of erasing an entire city from the map in minutes. Its name is USS Ohio. Enemy nations freeze when they hear that name. The world's most advanced military forces have poured billions into trying to track it down. And right now, no enemy on Earth knows exactly where it is. It may be sitting in some ocean, somewhere waiting in silence. Today, we pull back the curtain on that submarine. The most silent, most lethal, and most terrifying machine ever built by human hands. But before you understand how terrifying it is, you need to understand how massive it actually is. The Ohio-class submarine is 558 feet long. To put that into perspective, imagine the Washington Monument, one of the tallest structures in Washington, D.C., lying flat on its side. The Ohio class is longer. Now imagine taking 45 fully loaded Boeing 747 jumbo jets, fuel in the tanks, passengers in the seats, and sinking them all beneath the ocean at the same time. That is the combined weight of a single Ohio-class submarine. 18,750 tons of steel, nuclear power, and weapons, moving through the deep ocean at this very moment. And here is the part that should stop you cold. Something this massive, this heavy, this enormous, was engineered to completely disappear, not to hide behind a rock, not to sit still on the ocean floor, to actively move, to patrol, to hunt, and to remain invisible for months at a time, without a single trace. No radar system on Earth can detect it beneath the surface. Satellites, which can photograph a license plate from space, become completely useless the moment this machine slides below the waves. Surface ships cannot hear it. Enemy submarines have tried to track it and failed. The ocean simply swallows it whole. During Cold War exercises in the early 1980s, the United States military ran drills specifically designed to locate and track these submarines. The equipment available at the time, some of the most advanced surveillance technology on the planet, could not find them. Not reliably, not consistently, in many cases not at all. But here is what makes this truly unsettling. It is not just the enemy that cannot find it. The United States Navy itself does not know exactly where these submarines are during a patrol. That is not a malfunction. That is the entire point. The moment an Ohio-class submarine leaves port and descends beneath the surface, even the commanders back on shore lose precise track of its location. It operates in deliberate, engineered silence, beyond the reach of anyone. Right now, there are Ohio-class submarines on patrol in both the Atlantic Ocean and the Pacific Ocean. Which specific waters? Nobody outside of a very small classified circle knows the answer. Is one sitting in the North Atlantic within range of Europe? Is another moving silently through the depths of the Pacific within reach of Asia? The answer exists somewhere in a locked room that most people on this planet will never enter. And that is exactly how it was designed. The invisibility is not an accident. It is the weapon. So the question that should be sitting in your mind right now is simple. How does something that weighs 18,750 tons, something longer than a football field and a half, move through the ocean without making a sound? The answer is not one thing. It is a layered system of engineering decisions, each one designed to solve a specific part of the silence problem. And together, they produce something that should not be possible. Start with the outside of the hull. If you could get close enough to examine the exterior of an Ohio-class submarine, you would notice something unusual. The surface is not smooth like a regular ship. It is covered in a layer of material that looks almost like tiles. These are called anechoic tiles. The word anechoic means without echo, and that is exactly what they do. When an enemy sends out an active sonar ping, a pulse of sound designed to bounce off objects and reveal their location, these tiles absorb a significant portion of that energy. The return signal that comes back is weaker, distorted, harder to read. The submarine becomes harder to resolve on sonar screens, but the tiles do a second job as well. They reduce the amount of sound that escapes from inside the submarine outward into the water. Every machine inside that hull, every pump, every generator, every system that runs produces vibration. The tiles act as a barrier, trapping that vibration inside, preventing it from leaking into the ocean. But tiles alone are not enough. The real enemy of silence is not outside the submarine. It is inside. Every piece of machinery that rotates creates vibration. Turbines, pumps, cooling systems, electrical generators. If you bolt those systems directly to the pressure hull of a submarine, you turn the entire hull into a giant speaker broadcasting noise into the surrounding water. Enemy sonar operators would hear it from miles away. The engineers who designed the Ohio class solved this with a system called rafting. Instead of mounting major machinery directly to the hull, they suspended everything on an intermediate structure, a machinery raft, which is itself isolated from the hull using shock-absorbing damping materials. The vibration is generated, it travels into the raft, and it dies there. It never reaches the hull. It never enters the water. The ocean around the submarine stays quiet. Then there is the propeller. The specific design of the Ohio-class propeller remains classified information to this day. What is known is that it was engineered to minimize something called cavitation. Cavitation happens when a propeller spins fast enough to create tiny bubbles in the water around it. When those bubbles collapse, they produce sharp, distinctive acoustic spikes that passive sonar can detect and identify from a significant distance. The Ohio-class propeller was designed to operate at patrol speeds without triggering that effect. The exact blade geometry, the exact specifications, locked away, classified. And then there is the heart of the entire system, the S-8G nuclear reactor. This reactor changes everything about what silence means for a submarine. A conventional diesel-electric submarine has a fundamental problem. It needs air to run its diesel engines. That means it must come close to the surface regularly, either surfacing completely or extending a snorkel above the waterline. Every time it does that, it creates an opportunity to be detected by radar, by satellite, by aircraft, by surface ships. The Ohio class never has that problem. The S-8G reactor runs on nuclear fission. It requires no air. It requires no surfacing. It generates its own electricity, scrubs its own carbon dioxide, and produces its own oxygen through electrolysis. The only reason an Ohio-class submarine ever needs to return to port is food and human endurance. The machine itself could keep running. The result is a submarine that can stay submerged, moving silently, for 90 days on a standard patrol. The longest recorded patrol by an Ohio-class submarine was 140 days, conducted by USS Pennsylvania. 140 days beneath the surface, without a single moment of exposure. The goal of all of this engineering is not to make the submarine completely silent. That is physically impossible. Every object moving through water makes some sound. The goal is far more precise and far more unsettling. The goal is to make the Ohio class sound like the ocean itself. Deep water is not quiet. It is filled with the calls of blue whales, with rain striking the surface from above, with the constant crackling of snapping shrimp, tiny creatures that fire off acoustic clicks so rapidly and constantly they create a layer of background noise across entire stretches of ocean. A great submarine does not aim for silence. It aims to blend, to make its acoustic signature indistinguishable from the natural sounds surrounding it. And by every available account, the Ohio class achieves exactly that. Now we get to the part that changes everything. Because until this moment, we have been talking about a machine that cannot be found. A machine that moves in silence, that blends into the ocean, that even its own commanders cannot precisely locate. That alone is extraordinary. But the silence is not the point. The silence exists for one reason, and one reason only: to protect what is inside. Along the back of every Ohio-class ballistic missile submarine runs a perfectly straight line of steel hatches, 20 of them, evenly spaced, cold and still. From the outside, they look almost unremarkable, just flat panels on a curved hull. But beneath each one of those hatches sits a vertical launch tube, and inside each tube sits a Trident II D5 missile, 20 missiles, on a single submarine. The Trident II D5 is not a weapon designed for a battlefield. It is not designed to sink a ship or destroy a military base or take out a single target. It was designed for something far larger and far more final. Each missile weighs approximately 59 tons. When a launch command is given, a steam-powered ejection system fires the missile out of its tube while the submarine is still submerged, still silent, still invisible. The missile breaks the surface of the water and the rocket motor ignites. It does not fly like an aircraft. It surges upward, accelerating through the atmosphere toward the edge of space. The range of the Trident II D5 is approximately 12,000 kilometers. That is over 7,500 miles. To understand what that number means in real terms, consider this. A submarine sitting in the middle of the North Atlantic Ocean, somewhere between the coast of the United States and the coast of Europe, is within range of virtually every major city on the European continent. London, Paris, Berlin, Moscow, all of them reachable from a single patrol position. A submarine operating in the Western Pacific Ocean brings Beijing, Tokyo, Pyongyang, and every major population center across East Asia inside that same circle. The Ohio class does not need to move close to its targets. It is already close enough, from almost anywhere in the world's oceans. But range is only the beginning. When a Trident II D5 re-enters the atmosphere, it is traveling at approximately Mach 24. That is over 18,000 miles per hour, faster than almost anything ever built by human hands. At that speed, the reaction time available to any missile defense system on Earth is measured not in minutes, but in seconds, and no system currently deployed anywhere in the world has demonstrated the ability to reliably intercept a Trident II warhead traveling at that velocity. By the time any radar confirms a launch and calculates a trajectory, it is already too late. Now comes the part that makes a single Trident II missile something different from anything else in human history. It does not carry one warhead. At the top of the missile sits a system called a post-boost control vehicle. After the main rocket motor burns out and the missile reaches its highest point above the atmosphere, this system ignites. It maneuvers independently through space, and it begins to release warheads, one by one, each one aimed at a completely separate target, sometimes hundreds of miles apart from each other. This technology is called MIRV, Multiple Independently Targetable Re-Entry Vehicles. One missile, 8 separate warheads, 8 separate cities, 8 separate detonations. Each of those warheads comes in one of 2 versions. The first is the W-76. It carries a nuclear yield of 100 kilotons. The atomic bomb dropped on Hiroshima in 1945 had a yield of approximately 15 kilotons. The W-76 is over 6 times more powerful than that, and it is considered the smaller of the 2 options. The second is the W-88. It carries a yield of 475 kilotons. That is more than 30 times the destructive power of the Hiroshima bomb, delivered with an accuracy of approximately 90 meters. 90 meters. After traveling over 7,000 miles through space and re-entering the atmosphere at Mach 24, the Trident II D5 can land within the length of a football field from its intended target. And a single Ohio-class submarine carries 20 of these missiles. The mathematics of what that means on the ground is something most people have never been asked to consider. 1 submarine, 20 missiles, each missile splitting into up to 8 independent warheads, each warhead capable of destroying a city. The payload of a single Ohio-class submarine, fully loaded, can reach up to 160 separate targets across an entire continent with the accuracy of a precision-guided weapon. Somewhere in the Atlantic and somewhere in the Pacific, Ohio-class submarines are on patrol right now, carrying exactly this payload, waiting for an order that, in all likelihood, will never come. But the fact that the order could come at any moment from a machine that nobody can find is precisely what keeps the world from testing the alternative. Let us talk about what actually happens if the order is ever given. Not in abstract terms, not in policy language, in real terms, with real places and real numbers. An Ohio-class submarine receives its firing orders through a very low-frequency radio system, one of the few communication methods that can penetrate seawater at depth. The signal arrives. The commanding officer and the weapons officer authenticate the order together. Following a strict 2-man rule, that ensures no single person can initiate a launch alone. Verification codes are confirmed. Launch keys are turned. The sequence begins. From that moment, all 20 missiles can be fired in less than 1 minute. Not one at a time over the course of an hour. Not sequentially with long pauses between each launch. 20 Trident II D5 missiles, leaving the ocean in a ripple fire sequence, one after another in rapid succession, in under 60 seconds. The submarine remains submerged throughout the entire process. It never surfaces. It never exposes itself. It fires from invisibility and returns to invisibility the moment the last missile clears the water. Now follow those missiles. Each one accelerates upward through the atmosphere, climbing toward the edge of space. The boost phase lasts a few minutes. Then the post-boost control vehicle separates and begins releasing warheads, each one locked onto a separate target, each one falling back toward Earth on its own independent trajectory. The entire flight from launch to detonation, covering distances of thousands of miles, takes approximately 30 minutes. 30 minutes. That is the amount of time that stands between a launch order and the end of a nation. Consider what that means for a specific scenario. An Ohio-class submarine on patrol in the North Atlantic, operating somewhere in the deep water between the eastern coast of the United States and the western coast of Europe, is well within range of the entire European continent. If a launch order were given from that position today, missiles would be in the air within 60 seconds. Warheads would be separating above the atmosphere within minutes. And approximately 30 minutes after the first missile left the water, London, Paris, Berlin, Warsaw, and Moscow would all be within the impact window of independently targeted warheads arriving simultaneously or within seconds of each other, with no meaningful ability to intercept any of them at Mach 24. Now move to the Pacific. An Ohio-class submarine operating in the Western Pacific, within its normal patrol range, brings an entirely different set of cities into the same equation. Beijing, Shanghai, Tokyo, Pyongyang, Seoul, all of them reachable, all of them within 30 minutes of a launch that nobody would see coming, from a platform that nobody can locate. And here is the number that puts all of this into its full context. A single, fully loaded Ohio-class submarine, firing a complete salvo, releases up to 160 independently targeted warheads across a continent. 20 missiles, each carrying 8 warheads, each warhead more than 6 times the destructive power of the Hiroshima bomb. The combined payload of one submarine, in one patrol, on one day, is enough to eliminate the critical infrastructure, the population centers, and the governing capacity of most nations on Earth. But there is not one Ohio-class submarine on patrol. There are 14 ballistic missile submarines in the Ohio-class fleet. Together, those 14 submarines carry approximately half of the entire active strategic nuclear arsenal of the United States. Half, from submarines alone. Moving silently through the Atlantic and the Pacific right now, undetected, untracked, and fully armed. No air defense system stops them. No missile shield intercepts them at Mach 24. No military response can outrun a warhead that is already falling from the edge of space. The window between detection and impact, if detection even occurs, is too narrow for any defensive system currently deployed anywhere on Earth to close. This is the weight of what the Ohio class actually represents. It is not just a submarine. It is not just a missile system. It is a guarantee written in steel and nuclear fire, sitting silently beneath the ocean, that says to every government, every military, and every leader on this planet, that no matter what happens on the surface, no matter what is destroyed, no matter what is lost, the answer is already out there, waiting, invisible, ready, and nobody, not your radar operators, not your satellites, not your most advanced anti-submarine forces, will ever know exactly where it is. We started this story with a question. Right now, somewhere beneath the surface of the ocean, something is moving, and nobody knows where it is. That was not a dramatic opening line. That was a fact. At this very moment, as you watch this video, as you go about your day, as governments hold their meetings and militaries run their operations, Ohio-class submarines are on patrol, in the Atlantic, in the Pacific, moving in silence through water so deep that sunlight never reaches it, carrying enough firepower to end nations, and no one on Earth outside of a locked, classified room can tell you exactly where they are. Not your government, not your military, not the most advanced surveillance systems ever built. The ocean keeps its secrets, and the Ohio class is one of them. Think about that for a moment. The most destructive weapon system ever created by human hands is not sitting in a visible silo somewhere on a map. It is not parked at a base that you can point to on a screen. It is beneath you, beneath the water, moving, waiting, silent. And it has been there, in one form or another, every single day for over 4 decades. The Cold War ended. Treaties were signed. The world moved on. But the submarines never stopped patrolling. They are out there right now, the same way they were out there yesterday, and the day before, and the year before that. That is the Ohio class. Not a relic, not a museum piece. An active, operational, fully armed machine of absolute consequence, doing exactly what it was built to do, disappearing. And the most unsettling part of this entire story is not the missiles or the warheads or the 30-minute window. The most unsettling part is the simplest one. You will never know when one is near you. Nobody will. That is the point. If this video made you see the ocean differently than you did before you clicked play, then we did our job. Drop a comment below and tell us, did you know the Ohio class was still actively patrolling today? Because most people have no idea, and the ones who do never forget it. If you want more stories that pull back the curtain on the weapons, the machines, and the operations that shape the world most people never see, subscribe now. Every single video we make is built for people who want the real story, not the surface version. We will see you in the next one.